everyone, and welcome back to my channel, #analytics. For this demonstration, I will be showing you on how to code in Python for simple regression and multiple regression. So for this purpose, the question is why we are doing a simple regression or multiple regression. Okay, when we say simple regression, we are only using one dependent variable and one independent variable. So this is cause and effect. Our effect here is our y variable, and the cause is our x variable. Okay, for example, this is my data. For academic, this is the academic performance grade of a student, for example. So this will be our x variable or our cost. Then this one, nchi result, okay, this is our dependent variable or the effect. So the objective here is we want to determine if the academic performance have a significant impact to the nchi result. Okay, so to do that, we will do some simple linear regression analysis in Python. So let's start coding in Python, and I am using a Jupyter notebook. So where you can type your code and generate your output here in this Jupyter notebook. To start with working with our regression, of course, we need to import the library. So a library, pandas library, import the type import. Then the pandas library. So the purpose of this pandas library is for you to manipulate the tabular rows and columns. So, and we assign a variable for that library as PD. Then we are going to display or we have to, of course, before we do that, we are going to use the matplotlib live. So this will allow us to create that function pyplot to create some figures and graphs. So we use a variable as plt, okay, or plot. So you can assign any variable if you want. Then after that, we are going to read. Now we are reading the variable. So we have to assign a variable, for example, data, for us to read our data sets in an Excel or a CSV file. Then all you have to do, since this particular library, uh, which is represented as PD variable, so we use that because that allows us to manipulate rows and columns. Then we have to read underscore our CSV. Why CSV? Because the file that we have is a CSV. The file name is single CSV. So let's go back to our Python. Then in the parameter, of course, how do you type your file name in your Excel? Then, of course, it is exactly the same here. Okay. Then for you to know the values of your CSV, so all you have to do is to type the data because we have already stored our CSV in that variable. Then you run it. So how to run? By just clicking this icon, run. Then automatically it will provide you. So, oh, we have here. So we have to change our, because why we have here this one, because previously I have made some deletion for my Excel file. And okay, so let's make a new file for this to remove that none. Okay, meaning I have typed previously the figures here. Okay, so let's copy this one and create a new file. Okay, because I just deleted some values earlier, so it will automatically read. Okay, by then copy file, then new, then we have to click a new file here, values. Okay, then sorry, so values here. We can round it off. Then we save as, and save that in my Python folder, and the file name. So let's say simple. Okay, simple. Then extension file is CSV. Our CSV file, then save. Okay, so now let's go back to our Python and okay, change this to simple CSV. Then try to run. What happened? Then there we have it. Okay, because I just put some value there earlier. Then after doing that, okay, we need to do some calculation. For example, if you're going to calculate the mean, so you have to use this particular variable data. So example, you are getting the mean of that value. All you have to do is equals to mean, then the parameter. Okay, so then the mean function. So this mean function allows you to calculate the mean of your data. Then run. So, oh, sorry. Uh, okay, sorry for that. Then that you have to call the function mean. Okay, and then you have to run it. Then there you have your mean for your academic, and for NCAI is 66. Later we will check, we will manually calculate if this is correct. Then that is the mean per column. But if you're going to since if you're going to check, if you want to make the average of or the mean of per row, all you have to do, if you just want it to you know, you have to type of course your variable for your data sets, then the location, then the square bracket, no, then you start with colon is 0, then the attributes that we have here is the academic, no, the academic and NCAI. So you can type it here, academic to NCAI, then NCAI. Okay, then after that, you have to call the function mean, and the access, since this one is equal to, equal to 1, because the values here is, this is 0 index, then this is the 1 index. So the values that we're going to get is position in the first index, or then go back to the Python 1, then run. Okay, then there we have it. This is the mean of the two attributes. Okay, if we're going to let's try to calculate the mean, if that is correct. Okay, so 77. Okay, so let's check in our Python, is 77. So if you round it increase the course, that's the average. So we have here our mean for the two attributes. Okay, now let's proceed to store our values in an array. So our x here serve as our independent variable. So our x here in our datasets is the academic, and our y variable is NCHI. Okay, to do that, so let's code. So x is equal to data, data dot, of course, our index location. Then array colon. Then we start with 0, 0 to 1. Okay, so location of our x that values Then we store, of course, our y variable, which is our nchi. So data, so that's the variable that we assign for our data sets. Then our y is located 0, colon is 0, and 1 because this is our 0 and 1. Okay, 0, 1. So 1 position our, because our index 0, 1 for our x. Okay, then this one our y variable, that value. So now we have already stored the value in an array. So this is our dependent variables, and this is our independent variable. Okay, so then run it. Value, sorry, forgot. Okay, so we have already stored. Then now you are going to use the sklearn libraries for our model. Okay, so from sklearn dot model, then selection, then we import our train test class, train test split class, because we're going to split our data sets here. So we have our x training. When you say training and testing, for example, we have 262. Okay, so we assign 30% of 262. So what's that 30% 262? So if we're going to calculate that, so if we assign calculate, okay, so 262 point 30%, so we will use 78.6 or 79, okay, values in random as our um, testing data sets, and the remaining, okay, the if we have 79 values minus 262, so we have 183, okay, data sets which will serve as our training data sets. So our x train, then our x underscore test, our x variable is our academic attributes, then our y, okay, train, then we also y variable, which is our dependent variable, the nchi. Then we will split that one. Okay, this is the class that we imported. Then test split. Then our x and y. Of course, x is our independent, and that is our academic. Okay, academic. No, this one, the academic attributes and the nchi. So this is our x, and this is our y variable. Or x is served as our independent variable, and this is our dependent variable. So we will assign a 30%, okay, splitting of our data. So test size, okay, is equal to 30%. So that's 79 out of 200 as we calculate earlier. Then we select that randomly. Start with 0. So you select 30% of 262 randomly. Then run. Okay, then now we're going to import the linear regression. So regression class. So by typing from sklearn dot linear model, then we import our linear regression, import linear regression class. Then we will store that linear regression object. So to this variable, for example, our variable is simple regression. Okay, is equal to the our object. So meaning our linear regression object is stored in this variable simple regression. Then we have to put our simple regression, that's our variable for our linear regression object. Then we feed that the X training for our training data sets and our Y training data sets train. Okay, so that's 180 as we calculate 183. Okay, out of 262. So we build already our training data sets for linear regression. Then then run by clicking this button. So we have already our linear regression model. So next in this one is we are going to do some chart. So by creating the scatter for this one, so type scatter. Then of course in our scatter plot, so we have to reflect the values, okay, of the x variable, which is our academic attributes, and our y, which is our what do you call this, our NCHI attributes. Then we assign a color green, okay, sample for the values. Then we do the prediction. So we do the plot, then the X trained, and our simple, the variable of our object linear regression is simple reg. Then we predict, calling the prediction function of our X, which is our train. The X is our academic, okay, attributes. Then we assign a color blue, okay, that's a prediction line. This will generate a prediction line. Then these are the values, okay, of our training data sets. Then if you can also do some title of your linear regression, example title of your chart. There's a linear regression, okay. Then your PLT plot, the X label that we have is our academic performance. Then our Y label is our NCHI, okay, result. Then let's try to show the chart by using this show function. Then run. Okay, there we have it. As you can see, So looking at the values, the represented in green lines, so it was there's no significant impact, no, to the academic. Is no significant impact to the NCAI because of the values. Then let's see if we're going to calculate the values that determines, no, if there's a significant values or not by looking at the prediction, the y-axis prediction. So we will do some variable example. We're using a variable for prediction for our y-axis. So we will predict then equal to our simple regression object that we assign for our linear regression object. That simple reg, then dot predict function for our x test, because this one is the prediction for our training data sets and this one for x test. Okay, so then from sklearned import we the matrix of evaluation. Okay, one of the matrix of evaluation is the r square. So then we assign r square as our variable to generate the matrix. Okay, performance matrix. So our class matrix that r squared, that's our function. So we will test the y. Y is our the effect or the dependent variable. Then test, then y, then we predict that one. Okay, then let's show. So this will generate a particular matrix of r square, error in simple linear, simple linear. So the rule here is if it is the values generate closest to 1, so it means there's a significant impact. So and our variable r square. So let's see. So what's the generated results for using this matrix? Okay, then run. Okay, we have, okay, so we have here, okay, you can use comma. I forgot to incorporate comma. You can use single quotation. Just copy, or I forgot to type here the comma. Okay, you can use both here or a single quote. Okay, for the linear regression, so I position it incorrectly, that one. Okay, then r square, then run. Oh, the test is not defined. Why? That, oh no, sorry. So that's underscore test. Okay, y test is not defined. Wait, okay, so we have already the y test there. So just copy. So write it carefully because it will encounter some syntax error. So it's not defined, so which means because there's no underline, and we define our y test here in our previous code. So we have here, yes, that one. Okay, so then run it. Okay, so we have this value. So this is very far from 1. So which means that there is no significant impact. The academic performance has no significant impact to the NCAI result. Okay, that's the looking at this graph, you can already do some analysis that there's no significant impact because the dots, okay, or the values are too far from each other. And for you to know the numerical representation based on the matrix of evaluation, the R square, you can now determine or that these are the values that we use in the academic performance as no significant impact to the NCAI result. And if you do some prediction for the Y, you can enter some values here, okay, to determine. So if, for example, if you're going to predict some score, example, if my score is, okay, 65, okay, so let's try if, okay, let's double square here. So if I got 75 score and okay, let's check, sorry. So -9. So it's not good at of it's -9. So let's do some, right? If I'm going to predict a score of if I got a score of, let's call this 85 or 90, let's say 90. So what happened to the prediction? Okay, closest to 1. So this is a significant impact if you got a 90, okay, 90 score in your academic, okay, because our y variable here is the dependent variables, the NCAI. So if you have 890, okay, then there's a significant impact to your NCAI result. Okay, so this is the simple linear because we're just using the one independent variable and one dependent variable. And now let's proceed to the multiple regression. If we're dealing with multiple regression analysis, then we need one independent variable, which is our y variable, that is the effect, and we have two or more independent variables that are the x variables. So still using this code, so we will just modify to do a multiple regression. Okay, so let us check first our data sets. Again, the goal for this data set, so these are the data sets. So this would be, the NCAI would be our y dependent variable, and these are the x variables or our independent variables, or what to say, the predictors. Now the goal here is we would like to know if this particular variables have impact to the NCAI. So let us check. Okay, the process is still the same in coding the multiple regression. All we have to do is to change the location. And of course, we have to change our CSV. So the file name is multiple, okay. Then we rerun it again, then run. Then there we have it. So as we can see, we have other, because I have uh, write some values earlier. So, but we will not include that. But for safe purposes, so we will do some another no file for it. So copy, then create a new file. Okay, just to ensure that there's no other values here. Then file, save as. Okay, then save in your Python folder. So multi. So we change it to multi1. Okay, that's our new name. Then type CSV, select CSV file. Okay, then we go back to our Jupyter notebook. Then you can change that parameter to multi 1. Okay, just for you to know the difference why we have this one, because I typed earlier some values and some deletion, then run. Okay, so we have already removed those parts. Okay, those blank values. And now, of course, if we're going to generate the mean of each column, okay, you have to run it, that one. So you have already now the mean of each column. Then if you are now calculating again the mean of per row, so we start from our, this is our data set from English to NCHI. So go back. So you have to change this one from English to NCHI. Then of course we start our reading index 1 because we position our values in index 1 because this is index 0. So going back, then you run it. Okay, there you have it. So this is now your mean per row. Of course, for the location, so we do some changes here. So we will start at 0, the 0, then meaning our y for x variables, so -1, which means, what do you mean by this one? So if this is our, okay, table, so except this one, because these are the x variables. So -1 from 0, except this one. So this will not be included in our, this part will not be included in our x position location, data location. So going back to our Python. So here, okay, except for the last value, then our y data is 1. So this is only the position, okay, 1 here. We have only one column for our NCHI. That is our y variable, or independent variable, or the effect. Now, so of course, again, we still use this one, and you can change the test size. It depends upon you. If we're going to change to 20%, so it's okay. So you're going to change 30%, but not 40%. No. And then, okay, then of course you have to incorporate your linear model and do some uh, linear regression class. You have to import the linear regression class. And this linear regression, okay, object, still the same. We're using the multiple regression. So what's the difference is that we have 3 variables for this multiple regression. You can change this one to multi-reg. So it's dependent upon you. You can still use that variable, but if you want to change, to just change it to multi-reg. So we feed our training data sets in this class, our linear regression. Then try to run it again, and there we have it. Then for this one, so we have to do some positioning because it's not possible to have this part. So we will do some modification on this part. So we proceed to this one. So we have the multi-reg. Okay, then we do some prediction of our y variable from our dependent or independent variable, which is the English, the math, and the science. Then the matrix, again, the R squared, is one of the measurement for you to determine if those variables have a significant impact. Multiple regression. So multiple regression, square error. So multiple regression, where are we? Okay, this one. So I Incorrect this one. Multiple regression. So y. So this is our parameter. Okay, we test our y, or the dependent variable. Okay, for the R squared matrix. Then please run this one. Okay, run. Then let's check it out. So what happened? Okay, because I mistakenly put a comma here, and this will not be here. Okay, it will be here. Okay, I'll use that or that one. It's a single or double quote. Okay, then run. So we have here a calculate 45. It's too far from 1, because you can now determine if your of all the variables are significant. But for you to determine each variable, so how significant each variable, the English, the math, and the science to the n chi, so you have to generate some coefficient and the phi value. Okay, this we're just generating the R square error that determine, so if closest to 1, so there is a significant relationship or significant impact. So since there's no, this is too far from 1, so there's no significant impact. Okay, this is how you run your um, simple and multiple regression analysis. So I do hope that you learn from this demonstration. Okay, this is just an introductory of regression. So you can do some calculation about coefficient, okay, and the p-value, the calculated p-value of each variables. Okay, we're just presenting to you the R square measurement, the matrix, one of the matrix of evaluation, to determine if there is a significant impact or not. Okay, so that's all, and thank you for watching my channel, hashtag analytics.